Finding inverses of functions. We are finally here. We talked about what is an inverse. We talked about notation. We talked about how we can determine if two functions are inverses of one another. And now we're at the point where we can find an inverse. At least we will be after this lecture, after this video. So let's work through finding inverses of functions. So find the inverse of the function f of x equals the square root of x plus 7 on the domain of -7 to infinity. Find the domain and range of both f of x and its inverse. So our first step, we want to look at this in terms of x's and y's. So we're going to take this function, and instead of having an f of x, we're going to make it into a y. So we're just replacing f of x with y. So we start with f of x equals the square root of x plus 7, and we change it to y equals the square root of x plus 7. Not a difficult change, just one we're going to make first. Now, we said that an inverse function inverts the x and the y values. So the x values become y values, and the y values become x values. So it then makes sense that we're going to do that same exact thing with our function when we go to find an inverse. We're going to swap the x and the y variables. So the y becomes an x and the x becomes a y. Could probably shorten that up a little bit there. Now we have x equals square root of y plus 7, and we want to solve for y because we want to make this a function, a y equals function. That's what we're used to, right? Y equals stuff with x's in it. So that's what we're going to do here. We're going to solve for y. If I'm starting with x equals the square root of y plus 7, to get y by itself, I'm going to need to square both sides to get rid of this square root that's holding y captive. When we square a square root, it disappears. So we get x squared equals y plus 7. The square root is now gone. To get y by itself, I'm subtracting 7 on both sides. We get x squared minus 7 is equal to y, or y equals x squared minus 7. Now we're basically done. All we need to do is replace y with f inverse, because what we did was find an inverse. So this function right here is the inverse function of y equals the square root of x plus 7. Now, now, what was I going to do here? F inverse of x is equal to x squared minus 7. Now we have to be a little teeny tiny bit careful here, because x squared minus 7, if you think about it, is a parabola, right? And parabolas are not one-to-one functions, right? They are not one-to-one functions. Therefore, their functions are not inverses. So if we took the inverse of this guy, his function, it wouldn't be an inverse. It wouldn't be a function. His inverse wouldn't be a function, because this guy's not one-to-one to begin with. And we need to remedy that by restricting the domain. And we have some of this taken care of for us already. So find the inverse of the function f of x equals the square root of x plus 7 on the domain -7 to infinity. Our original function, f of x, had a domain, we were told, of -7 to infinity. Well, that means that the range of our inverse is -7 to infinity. And then think about what this function would look like. This is the function, the square root of x. The square root of x looks like this. This is the square root of x shifted to the left 7 units. So if you think about what that what that looks like, our original function looks like this. This guy's range is from 0 to infinity, the range. This original function has a range of 0 to infinity. So the domain of our inverse of this guy here is from 0 to infinity. Now, this in general function does not have a domain of 0 to infinity. This is a polynomial. It's defined everywhere. This domain is everything. However, the domain of this, when it as it relates to this function being an inverse, is from 0 to infinity. So we restrict the domain of this function to make sure that it's a function, that it's to make sure that it's one-to-one. So if you think again about what x squared minus 7 looks like shifted down 7 units looks like this. So instead of allowing this entire thing to be the inverse, we say, okay, no, not that whole thing, just this portion of it, because just this portion of it is one-to-one. And look, this is also what the square root graph looks like, right? Imagine flipping it over the line y equals x, and you're going to end up with that picture that I drew above. And that is our answer here. So sometimes, especially with domain, we need to look back at the original function and see what we know about that original function and apply it to the function's inverse. So we knew that this was the graph of a square root function that had been shifted to the left. We knew that that meant the range was 0 to infinity, and that allowed us to restrict the domain on this inverse to be appropriate, to make this function into an appropriate one-to-one function. All right. Find the inverse of the function below, then find the domain and range of both f of x and its inverse. These problems right here can be pretty troublesome for students, and I want to go through it slowly if I can so that we can be sure that you understand how to do this. The first step, of course, is replacing f of x with y. So we have y equals 2x minus 3 all over x plus 4. The next step is flip-flopping the x's and y's. So instead of y, I'm going to put x, and instead of x, I'm going to put y. So x is equal to 2y minus 3 all over y plus 4. No, I'm just going to leave it. We want to get y by itself now. That's the next step, is to get y by itself. But this is weird, right? Because we have y in the numerator and y in the denominator. And how can I separate those y's out so that I only have one y equals? And the steps are going to look, they're going to look very much the same every time you do a problem like this. I'm going to be intermittently pausing, writing down a direction, and then unpausing. So it's going to be a little bit broken up, this next problem. So give me a second. All right. So to begin with, we're going to multiply both sides by this denominator of y plus 4 so that we don't have this weird denominator and numerator having a y in it thing. If we multiply the numerator and denominator, the numerator, if we multiply both sides by y plus 4, it cancels out the denominator over here. And now you have y plus 4 times x equals 2y minus 3. So this is x times y plus 4 equals 2y minus 3. So when you're doing problems like this, it's always kind of like this, if it's a rational function with a linear over a linear, as this one is, it's the same process of you multiply the denominator over. So we multiply the denominator over. Now you have an x over here, and you're going to distribute, not do that, you're going to distribute that x. So we are distributing the x. we get xy plus 4x is equal to 2y minus 3. We want to get y by itself, so we are going to collect all the y's on one side and put everything else on the other. Okay. So, come back here. Terms with y's in them, we have this guy right here. He has a y in him. This guy right here has a y in him. We're moving those to the left side. So we're going to end up with something like this. Pink stuff equals blue stuff is kind of what we're going for here. So stuff with y's in it is pink. Stuff without y's in it is blue. I want everything with a y in it over here. So I'm moving this guy over this way, this guy over this way. So xy stays, right? He stays on this side. And then I'm subtracting 2y on both sides. So minus 2y, he's no longer on the right. 4x is moving to the right side. So I have negative 3 minus 4x. So this guy, I subtracted him over to the other side. The 4x, I subtracted over to the right side. And now if you look at what I have something where I have all y's over here. And if everything here has a y in it, then I can pull a y out. That's why it was important that everything on the left had y's and everything on the right didn't, was so that I could pull a y out. So I'm going to factor out a y. So I'm factoring out that y. We have y times x minus 2 is equal to negative 3 minus 4x. And then getting y by itself is real easy because we just need to divide both sides by x minus 2 and we're done. So I am taking this guy right here and I'm trying to get y by itself. I'm dividing both sides by x minus 2. That cancels. I now have y equals negative 3 minus 4x, all divided by x minus 2. And that's my inverse function. I just need to put my inverse notation on it. Bam. Now, part of this question also said to find the domain and range of both f and f inverse. So can I make some space on here maybe? Move some stuff up a little bit. Let's pause it and make a little more room. All right, so I made a little room on my page here. So here's our inverse function. Here is our original function, and we want to find the domain and range of both. So this is one of those situations where it's a lot easier to find domain than it is to find range. And so finding the range of this original function here is a lot easier to do if we just find the inverse and then the inverse's domain. So with here, we know that x cannot equal 4, negative 4. We have to take negative 4 out of the domain of the original function. This goes back to finding domains of functions, of rational functions. So the domain is everything except for negative 4. So negative infinity up to negative 4. Then we take negative 4 out, and we go from negative 4 to infinity. And that domain is the same domain, or same as the range of the inverse. For the inverse function, the domain excludes positive 2. Positive 2 is not in the domain of the inverse function. So the domain of the inverse is from negative infinity to negative or to positive 2, union 2 to infinity. And if it's the range of the inverse, then it's the, if it's the domain of the inverse, it's the range of the original. That's pretty cool. Bam. All right. 2 more problems on this page. Oh no, this messed up all my, there we go. By the way, if you didn't watch the first video in this sequence, in this series of videos, the intro to inverse functions, first of all, we did, oh no, where is that? Not that one. In the intro video, we did this problem here where we found the graph of f inverse. So if you're in this video because you wanted to know how to do a problem like this, then you need to go back to the intro video because that's where that problem is. But if you didn't watch that video, I am sick and my brain is very, very foggy. So if you've wondered why these past 4 videos have been a little bit scatterbrained, that would be why. At this time, I do not have the energy to try and record these videos 10 times to make them perfect. I appreciate your patience. Let's find this inverse. So find the inverse of the function below, then find the domain range of both f of x and its inverse. So this guy right here, f of x equals 6 minus x cubed. I'm going to start by replacing f of x with y. So y equals 6 minus x cubed. You know what? I'm almost thinking maybe I should change this function. Give me a sec. I might change this. All right. So for those of you in the future, you already saw that I had changed this function to a different one. I don't have the patience to figure out. The formatting and notability is super weird, so I just didn't type this part. Write this down. This is part of the instruction. I wanted to do one of these quadratic ones. I put in a cubic one, but the quadratic ones are actually a little more tricky, so I figured maybe we'd do one of those. So find the inverse of the function below. F of x is equal to x plus 3 quantity squared for the domain negative 3 to infinity. Right, so if we wanted to start keeping score over here of domains and ranges, if we know the domain of this original is negative 3 to infinity, then we know that the range of the inverse is from negative 3 to infinity. Now, x plus 3 quantity squared itself is, his domain is everywhere. We are simply saying that we are restricting his domain from negative 3 to infinity because we need it to be 1-to-1, and it is 1-to-1 on this interval. Right. So we have y equals x plus 3 quantity squared. We're swapping the x and the y. So we have x equals y plus 3 quantity squared. To get y by itself, we're going to need to get rid of the square. So we're going to take the square root on both sides. But when you take the square root on both sides, you have to put a plus or minus on one of the sides. So the plus or minus is going to go on the x. So plus or minus x equals, and I'm going to write the whole thing down, the square root of y plus 3 quantity squared. This square root will cancel out the square. And we are left with plus or minus the square root of x is equal to y plus 3. If we subtract 3 on both sides, we're going to get y equals plus or minus the square root of x minus 3. Now, we still need to figure out the range and domain issues here. And There's a few ways we can do that. Also, we have to finish the notation thing here and decide on a plus or minus. So, a few things here. One, we need to make it into our F inverse notation. But before we can finish writing this, we need to decide if it's plus or minus. And we also need to find the domain and range, which is really just one thing, right? Now, if we think about the function x plus 3 quantity squared, this is where it's really helpful to have your graphs kind of memorized, your base functions. That's the parabola x squared shifted to the left 3 units. And its x-intercept is going to be here at -3. So really, when we said that it was only on the domain from -3 to infinity, this is what the graph of that function would be. At x plus 3 quantity squared, restricted to just -3 to infinity, would look like this. And the range of this guy is going to go from 0 to infinity. From 0 to infinity. So that's one way that we could figure out the domain of f inverse, is looking at the graph. But another way that we could think about it is that this function f inverse here, regardless of whether we choose the plus or minus, and we'll talk about that in 1 second, requires that x is greater than or equal to 0. So the domain of this function, just on its own, without thinking about where it came from, itself would be from 0 to infinity, which would give us the range of the original. So either you can look at the graph of the original and use that to derive the domain, or you can look at just the domain of what this function is and use that to derive the range of the original. Now, the big question is, do we use the plus or the minus on the square root of x? Because we can't keep both in, that would make it not a function. And you have to think about, okay, the range on this guy is it has to go from -3 to infinity. The range. So the y values that come out need to be greater than -3. If we chose the negative part here, if we did negative square root x minus 3, imagine plugging in 4. If I plugged in 4, I'd get negative square root of 4 minus 3, right? If this was like f inverse, I'm going to erase this in a moment. If this was f inverse of 4, we plug that in, we would get -2 minus 3 to get -5. So you get a y value -5 that falls outside of the range that we know our f inverse has. -5 is not in that range. So we're not choosing the negative, we're choosing the positive. And that's to make sure that the range matches up with what the range is supposed to be based on the domain we were given originally. So we're choosing the positive here to be sure that f inverse has a range from -3 to infinity, and you can double check it by taking any x value, plugging it in, and making sure that the y value you get out fits within this range that we have over here. And that's that problem. All right, one last problem then. So the one-to-one functions g and h are defined as follows. We have g, which is a set of discrete points, so -4, 3, 4, -5, 5, 7, 8, 5, and 9, 2. And then h of x, which is a linear function, x minus 9 over 5. We're asked to find g inverse of 5, h inverse of x, and h inverse of h of 4. So let's approach each of these, let's approach each of these one by one. So for g inverse of 5, I want to bring us back to properties of inverse functions. One of the things we said was if a comma b is on the graph of f, then b comma a is on the graph of f inverse. And what that meant was if f of a is equal to b, then f inverse of b is equal to a. And if we come back here, we have all of these points here. Now, this input into the inverse function is an x value, right? It's an x value for the inverse function. but that means it's a y value for the original. So if I look at where the y value is 5 in this original set here, we have this point here, and this point here is g of 8 is equal to 5. If the point 8 comma 5 belongs to g, then g of 8 is equal to 5, which also tells us that g inverse of 5 is equal to 8. And that would be our answer. So it's remembering that the x values for the inverse are actually the y values of the original. To find h inverse of x, we're taking this function here, and we are going to swap x and y. So we would have x equals y minus 9, all divided by 5. I did 2 steps in one there. I want to get y by itself. I'm going to start by multiplying both sides by 5. I have 5x is equal to y minus 9. To get y by itself, I'm adding 9 to both sides. So we have 5x plus 9 is equal to y. So h inverse of x is equal to 5x plus 9. And finally, for part C, which is really uninteresting, h inverse composed with h of 4. This is h inverse of h of 4. And remember what we said in our properties of functions video, that f inverse of f of x, when you compose them, they just cancel each other out. So this h inverse of h thing cancels, and you're just left with 4. And that's that. So that is the big things to know about inverse functions. Really big thing is just going to be practicing. That's true of all of math. If you have questions, send me an email. Otherwise, I hope that you all stay healthy, you don't get sick, and that the rest of your day is wonderful and beautiful. And I will see you all in another video. Bye.